So in our notes today, we're going to graph a few more polynomial functions. They're a little different from what we've already graphed before, so just kind of keep that in mind. Okay, so there are some steps at the top of the page. So it says that we're going to factor if necessary. We're going to list the real zero and multiplicity. We're going to determine if it touches or crosses through the graph. And when it says touch it pretty much means bouncing. So if it bounces off of the x-axis. Step 4 is to find the end behavior and degree, so that's kind of helping you there. The last step that isn't written is to find the y-intercept. So that's the last bit, is finding the y-intercept. So we're not going to look at all of the questions. We're just going to look at 3 of them today. So we're going to start out by looking at example number 2. There's methods to my madness. Let's look at question number 2 first. So the first step says to factor if necessary. Okay, there's more than 3 terms, because usually if there's just 3 terms, then we can try to factor using the little X chart. Can't use the little X chart for this. When there's more than 3 terms, you can usually factor by grouping. But the issue is if I was to factor by grouping here, I can't because I have this 36 at the end. So unfortunately for us, I can't factor like I normally do when there's 3 terms, and I can't factor by grouping when there's usually 4 terms. When that happens, we talked about this last class period when we can actually figure out the actual zeros using the rational zero theorem. The rational zero theorem is only going to give us the possible rational zeros, but that's a starting point. Because if you think back again to what we did last time, after we used the rational zero theorem to find the possible zeros, we actually figured out which of the zeros were actually going to work for the polynomial that we had. So we're going to use the rational zero theorem to solve this. So at the top of the page, I'm going to actually write that out. So if you can't factor, which for this one we can't, so if factoring is not possible, you're going to use the rational zero theorem. So we're going to use the rational zero theorem. And that rational zero theorem is going to tell us the possible zeros, but we learned last class how to find the actual zeros using the possible ones. So that's what we're going to start off with part 1 of example 2. So I'm going to scroll down and we're going to look at example 2. So part 1 of this is to find the possible zeros. So I need to do P over Q. Well, in order to find my P over Q, David, what's my P value? The last term, so the negative 36. So I'm going to write that on top. And then what's the Q value? The first term, so that's that negative 1. Please don't say that that's an X. That is a negative 1. Let me actually put Q in that parentheses. I told you guys before, you can reduce that to make it positive 36 over positive 1. That's the only thing I say with reducing. Don't reduce the numbers, just the sign. It's not going to really make a difference if I was to put 36 over 1, so I'm just going to put my multiples, and I'm purposely making this a long numerator for a reason. So I know for the numerator and denominator, we're going to have positive and negative numbers. The denominator is quick and easy. That's 1. Positive and negative 1 will give me 1. Give me the numbers in order. I know 1 and 36 will be my multiples. 2 times what will give me 36? 2 times 18? 3. 3 times what will give me 36? 3 and 12. 4? 4 and 9. Uh-oh, getting close. And then after 4, it goes to 6, right? Okay, was able to fit that in. So I have 1, 2, 3, 4, 6, 9, 12, 18, and 36. Those are all the multiples. Just like what we did before when we were looking at the rational zero theorem last class, all we did from here was divide. So divide everything in the numerator by 1. So that shouldn't be difficult. We're going to put plus or minus. 1 divided by 1 is just 1. 2 divided by 1 is just 2. 3 divided by 1 is just 3. We'll do 4 divided by 1, which is 4. 6 divided by 1, which is 6. 9 divided by 1, which is 9. 12 divided by 1, which is 12. 18 divided by 1, which is 18. And then 36 divided by 1, which is 36. All of these are our possible rational zeros. So it looks like we have about, 18 different zeros that we might have, because there's 9 of them total and we're just doubling it, 1 positive, 1 negative. So it looks like we have about 18 zeros. That's way too many to check. We're going to start this off. If you think back to when we were doing rational zero theorem last time, we said that once we found an actual zero, if we could simplify it to something that was able to factor, then we could simplify it further just using regular factoring. And that's what we were able to do in this portion here. So all I need to worry about doing is try to simplify this just enough so I could actually factor it by grouping, factor it by the 3 terms. So use the, like, I think some teachers call it the AC method or the X method like I usually do, or even using quadratic formula. I just need to find what are the other x-intercepts. So for the next step, for step 2, we're going to go ahead and start using synthetic division. So using synthetic division, I'm going to take the leading coefficients from my polynomial. So that's -1, 2, 11, -12, and -36. Just to make sure there's no terms missing from this, right? 4, 3, 2, 1 constant. Nope, nothing's missing. We're going to take the first possible 0, which is +1, and we're going to start dividing. First step, bring down, then multiply, add, repeat. Okay, well, that's not fun. Check my math. When I did +1 to check to see if that was a 0, is this going to be a 0? No, it gives me a remainder of -36, so unfortunately 1 is not going to work. Okay, that's all right. Let's try -1. Do the same process, bless you. We're going to do the same process, but this time we're going to try with -1. Hopefully that changes our answer. All right, so we're going to bring down, multiply, add, multiply, add, multiply, add, multiply, and that's -16. Okay, again, -1 is not going to work. That's okay. The only way that you guys will likely make a mistake, because I was doing the exact same thing earlier today, is with the adding and subtracting inside of this parentheses. So be careful. As you guys are multiplying and adding, be careful. Okay, unfortunately for us, correct me if I'm wrong, positive and -1, those aren't going to work, right? Okay, good. Let's move on to 2. So let's try +2, and then if +2 don't work, let's see if -2 does. So +2, I'm going to recopy all of my numbers, and we're going to try to solve. So we're going to bring down, multiply, add, multiply, add. That's going to give us 10, 20, -16. Okay, doesn't look like 2 is going to work. Let's try -2. So right next to it, I need a little more space. Let's try -2. Recopy all of the same numbers. And let's bring down. It seems tedious and it seems like a lot, but once you can at least find 1 or at most 2 x-intercepts or 2 zeros, you'll be able to simplify a lot quicker. We just need to find that first one. We're going to multiply, add, multiply, add, multiply. It's -6. We're going to add. What's -18 times 2? Positive or negative? Positives. Oh, good. We do have one. Finally. All right, one of our x-intercepts, one of our zeros, one of our roots is -2. So this is going to be one of my x-intercepts. Let me scroll back up to the top. At the top, I'm going to write my zeros, or you can put roots, because those are your x-intercepts. One of the x-intercepts is -2. That's one of the answers that I need. So down here, let's kind of look at this for a second. I'll tell you this before I do it. Do not write what I'm about to put. So do not write what I'm about to put. This is my constant. This is x to the first, x squared, and x to the third. Because remember, the whole reason why I had to do this was because I couldn't factor the original problem. Let's see if I can factor this. So I have -1 x to the third power plus 4x squared plus 3x minus 18. What's the only way I could potentially factor this? By grouping. So I can group the first 2 terms and the last 2 terms. Let's try it. In the first group, what can I factor out? Just an x squared? Let's do a -x squared. What does that leave in parentheses? X minus 4. There we go. All right, in the next group, what can I factor out? Positive or negative? So we're going to factor out a positive 3 in parentheses that are squeezed on there. What can I put in there? X minus 6. Do these two things match? Okay, so unfortunately, luckily you guys didn't write it. If you can't factor, which in this case, technically you can try, but this one won't be able to factor nicely. So all of this stuff in purple that I wrote, I'm going to erase. And you guys on your clean paper are now going to continue. We've already tried negative 2. Let's try, what was the next number?
3.
Positive 3. Let's try positive 3. Hopefully that works. So down here, I'm just going to continue this. We're going to put a positive 3. And we're going to keep going. So I'm going to bring down. We're going to multiply. This is negative 3. Add. Multiply. So 6. 6 times 3 is 18. Oh, good. We have another 0. So at the top of my page, I'm going to put 3 because that's my other x-intercept. The whole point of this is to ask you to graph it. So I know at least 2 of the x-intercepts so far. If you look back at the original problem, since it's x to the 4th power, that's your exponent. The highest exponent is a 4. That means you're going to have 4 x-intercepts. We talked about this. When you have an even degree, you're going to have an even number of roots. So now I need to find out what are the other roots. So using this information that's down here, we're going to go ahead and try to find that. This is only a trinomial, so I could probably end up factoring this. So over here to the side, if you run out of space, guys, the entire back side of your packet is blank. So we're going to make this negative x squared plus x plus 6. We want to factor and solve. Okay, so looking at this problem here, the first thing I definitely want to do is factor out a negative. So out of here, I'm going to factor out a negative 1, if I could write this in pen. That's going to leave in parentheses x squared minus x minus 6. Check my signs, make sure they look good. In this parentheses, this is just a trinomial. So let's see if I can use the x method, my little chart like this, to see if I can factor. I need 2 numbers that multiply to negative 6, but add up to negative 1. Chelsea, what 2 numbers can I use? If I need 2 numbers that multiply to negative 3, or negative 6, but add up to negative 1, which one needs to be negative? The 3. Since the leading coefficient in this parentheses is a positive 1, I can rewrite this as negative 1. That leading coefficient stays there. Negative 1, parentheses, x minus 3, and x plus 2. This is what we'll set equal to 0. So I'm going to set, let me see if I could squeeze equal to 0 behind that. We're going to make x minus 3 equal to 0 and x plus 2 equal to 0. The negative 1, good question. That's a leading coefficient. You don't need to rewrite that with any part of your solving. It's not going to change your answer. That leading coefficient here, if there was a variable next to it, then yes, I would set it equal to 0. But since it's a number, you don't need to set it equal to anything. All right, so the last thing I need to do is just simplify. So x is going to equal positive 3, and x is going to equal negative 2. Where have I seen these numbers before? You're pointing. What does that mean, Edgar? Those are the zeros. Those are the actual zeros I already have. So what does that mean if I have these other x-intercepts? The multiplicity is going to be 2. Good job, Fatima. So up here at the top, I'm going to add in negative 2 again, positive 3, and I'm going to make a note that these are going to be multiplicities of 2 because I have 2 of the exact same x-intercepts. So over here to the side, I'm going to put x equals negative 2 and x equals 3. For both of those x-intercepts, I'm going to make a note they're going to have a multiplicity of 2, multiplicity of 2. And if you look back at the directions at the top of the page, step 2 said to list each real 0 and the multiplicity. Step 3 said to determine if it crosses or touches the x-axis. So since both of these are multiplicities of 2, how are they going to touch the x-axis? Are they going to cross through it or bounce? They're going to bounce off. All right, so I have my x-intercepts. Remember, all we're doing right now is graphing. Once you have the x-intercepts, step 4 at the top says to determine the end behavior. With the space that I have, I'm going to try to make some space, but you might need to use the back side of your page. Actually, you know what? I'm going to use this upper space up here. All right, so for step 3, I think this is, on my paper, We're going to find the end behavior. Let me make sure. Step 1 was the P over Q. Step 2 was synthetic division. Yes, this is step 3 for me. All right, for the end behavior, I need the leading coefficient and I need the degree. Jenny, what's the leading coefficient for this problem? -1. And what's the degree? 4. Okay, so we have a negative leading coefficient and an even degree. What does that mean for your end behavior? What's going to happen? You can look back at the other page if you need to. If you need to, guys, flip back to the other page. This is a memory from Algebra 2, but if you don't remember it, commit it to memory again. Don't be guessing. I'm asking Jenny. Jenny, we're on this page. This was the very first page I gave you guys. When you have a negative leading coefficient and an even degree, what's going to happen? Down, down. Both ends are going to be going down. Guys, this was the very first page that we went over when we were reviewing polynomial functions. So if you need to get this one out, get it out. All right, so down here, we're going to have the end behavior is going to be down in both directions. Let me write that out. And there's methods to my madness. I know what my graph should look like. The last thing is the y-intercept. In order to find the y-intercept, what do I need to plug into this equation again? 0. So if I plugged in 0 and I got the y-intercept, what would it be? -36. So over here to the side, I'm going to make my y-intercept -36, and we're going to graph all of the things that I just wrote. I knew that this was opening down in both directions, which is why I use this little upper space, but you can't always do that. All right, so let me zoom out just a bit. I'm going to go ahead and use my red pen to graph. We're going to plot our x-intercepts first, which are over here at -2 and, +3. Our y-intercept is going to be down here at -36. And from here, we're just going to graph. We're going to start in a downward direction. Since at -2, we have a multiplicity of 2, I'm going to bounce this off of the x-axis. We're going to keep going through the y-intercept. Just make it touch somehow. You can have it cross through. And then I'm going to have it go right back up to +3. And it should look something like this. That should be your graph. Since we have everything we really need, there's one last thing I want to put, just in case I ask you to write this on a test or quiz, and this is your factored form. So factored form pretty much means if I was to factor all of this, what would it look like? In this equation, what's the leading coefficient? -1. So y is going to equal -1. In parentheses, I'm going to put the x-intercepts. But when I write the x-intercepts, I'm going to put them as factors. How would I write these as factors, Jacqueline? Let's start with x equals -2. What would that look like as a factor? And what should your multiplicity be here? 2. So I'm going to put a degree of 2 here. Next one. X minus 3. And say it again. Multiplicity is 2, so I'm going to square that. Good job. Is there anything else I need? No, that's it. Once you FOIL this out and once you solve it, that's when you get your y-intercept of -36. So don't worry about putting a -36 at the end. This in yellow would be your answer. So remember, if you want to, and instead of putting that -36 at the end or trying to FOIL everything out, if you were trying to find a y-intercept, you can plug in 0 for this x and 0 for this x, and you can simplify it that way because that will actually give you your y-intercept because your x is equal to 0. And I also want to make sure, I just thought of this. Since this -1 is in front, we didn't just put it in front because we have this -1 here. The reason why we put it in front is because we factored it out earlier. Look back in this corner right over here, we factored out this -1. That -1 needs to be part of your answer because it is part of your leading coefficient. So since it's a part of your leading coefficient, it needs to be part of your final answer. So make sure that that -1 is stuck next to your factored form at the front. So right now, I want you guys to start with number 3. So flip it over to the next side. You're going to do the exact same process. Find the possible rational zeros. You might need to use synthetic division, and then graph it after you found everything you need. So I'm going to give you a 2-minute head start. First things first, find your possible rational zeros. Start with 1 and then work your way up. So here we are. Question 3. Look at my page. Make sure that you're on question 3. And I'm going to give you 2 minutes. First step, find P over Q. All right, so really quick, just making sure you have the right possible rational zeros. Make sure that whenever you do have these, especially this 4 over 2, don't reduce it. Keep it as it is, and then just write the multiples for 4 and the multiples for 2. Because if you try to reduce it, you might potentially miss out on one of your x-intercepts that your equation should be. All right, I'm going to give you guys another 2 minutes. Start out with, I don't know, positive 1. See if that one's going to give you an answer, and then keep going down until you find at least 1 or 2. Since this one has a degree of 5, that's the highest exponent, you're going to have 5 x-intercepts. You're going to have 5 zeros. Find all 5. So 2 minutes. After that 2 minutes, I'm going to check to see how it looked with positive and negative 1, and potentially positive and negative 2. So 2 more minutes. All right, so we've already talked about this a bit. You guys already told me that positive 1 is not going to work as one of the solutions. It doesn't give you a 0 for a remainder. So I'm going to check negative 1. This will give me negative 2, negative 7, positive 7, 3, negative 3, 8, negative 4, negative 8, then negative 4, then positive 4, which gives me 0. So one of the zeros that you should definitely have, I'm going to write this at the top, one of the zeros that you should have is definitely negative 1. So that's one of the x-intercepts. Okay, the next number is positive 2. If I try positive 2, let's see if that one works. So I'm going to go from here. We're going to look at positive 2. Multiply, add, multiply, add, multiply, add, and multiply with 0. So this is what I have. So up here at the top of the page, I'm going to put x with my 2. I could definitely try to rewrite this using the 4 terms. I could rewrite this as a polynomial. This is a constant. This is x to the first, x squared, and x to the third power. But especially since there's a possibility, I'm not really too sure if I can actually factor this nicely because I'm seeing the 2 and 3 here, and I'm seeing the 3 and 2 here. I don't think I could probably factor this very nicely. Let me do this one more time to see if I can actually find another number. Negative 2. Did negative 2 work for you guys? No. Okay, no. All right, we'll move on to the next number. What was the next one? 4? Positive 4? No. Nope, that didn't work. Negative 4. 1/2? Yeah. Okay, let's see. Let's make sure 1/2 can work. Of course, on your tests and quizzes, guys, if you have to go through most of these numbers, it's okay. It'll work. So we said 1/2. Let me bring it down. Half of 2 is 1. Don't let that fraction freak you out. Half of 2 is just 1. Negative 3 plus 1 is going to give me negative 2. Half of negative 2 is negative 1. Negative 3 minus 1 is negative 4. And half of negative 4 is negative 2. That's my other 0. So up here at the top of the page, let me add in this 1/2. And I'm also going to take what's left over and I'm going to factor. So I think I have space, right below it. I'm going to go ahead and rewrite this to factor. So 2x squared minus 2x minus 4 should equal 0. Hussein, how should I factor this? What should I do? Okay, factor out of 2 first. Now I need to factor what's left inside the parentheses. So how can I factor that? What should I do? I need to find 2 numbers that multiply to what? What 2 numbers can I use? Try it again. There you go. When you make that 1 negative, it's not going to give you a negative 1 down here. Okay, since I have that, and since you told me to factor out a 2, I now have a leading coefficient of 1. So that means you can rewrite both binomials as x minus 2 and x plus 1 equal to 0. Bless you. By the zero product property, guys, just take both of the binomials. Don't worry about the 2. That's your leading coefficient. Take both of the binomials, set them equal to 0, and solve. So one of the x-intercepts, Hussein, what was one of them?
2.
And what was the other one? Okay, that looks like the other two x-intercepts that I have, and I'm actually glad that y'all went through almost all of the possible rational zeros to see that these two other x-intercepts were actually the other ones that you were missing. When you're solving them, that's why I'm saying you can go through all 18 or all 20 different possible zeros that you have, but especially for this question, it looks like how Fatima told me earlier, you're probably going to have a multiplicity of 2 for at least some of these problems here. So I'm going to put a -1 and a 2. So this one looks like a multiplicity of 2 for 2 of them. Mm-hmm. You won't have to necessarily go through all of them. That's why I told you guys, once you simplify it enough, because technically if we would have stopped right here, you could have tried to simplify using factoring by grouping. I just want to simplify it enough to where I could actually factor it and get a number. Remember, we couldn't factor this one, right? That's why I did it one more time, because after this point, even if you can't factor it, what could you use instead to find the x-intercept? Begins with a Q. Quadratic formula. Does that make sense? So you might not have to go through all of them. Hopefully you won't. But if you do, you can always get to at least 3 terms and use quadratic formula that way. Does that make sense? All right, so I found all the zeros. Let me make a note over here as to what the zeros and multiplicities are. So we're going to have x equal to -1, x equal to 2, and x equal to 1/2. There's a multiplicity at -1 of 2. Multiplicity here of 2. And when x equals 1/2, what's the multiplicity? Just 1. I'm going to make a quick little note that these are going to bounce, and this will cross. Almost done. All right, I need to label what the end behavior is going to do, and I also need to label what the y-intercept is. So below the graph, with my space that I have, we're going to talk about the end behavior. So in the end behavior, if I can find a color, Gabriel, what's the leading coefficient for this? What was the leading coefficient? Positive or negative? This is a +2, and what's the degree? So if you think back to the other page, what does that mean for your end behavior? What's going to happen? You can flip back if you need to. So, okay, so it's going to go down, then up. Okay, so we're going to put down, then up. And then the last thing I have for you, Gabriel, is what's the y-intercept? That's what I'm graphing. So with my graph, I'm going to start at -1, which is right here. Let me do this in red like I did on the last one. I have 1/2 here. I have 2, and we'll put -4 somewhere down here. All right, so at -1, it's going to bounce. So it's going to start in a downward direction. It's going to bounce off of the x-axis. It's going to go through the y-intercept. At 1/2, it's going to cross through. Just moving that over just a bit. All right, now, good. It crosses through, and it's going to bounce off of the x-axis one more time and keep going up. On your tests and quizzes, guys, I just want to make sure that it crosses through the values it's supposed to cross through, it bounces off of the values it's supposed to bounce through, and it ends in where it's supposed to. So down, up, down, that information. Last thing that I need, Fatima, is the factored form. Okay, say that one more time. X plus 1 squared, x minus 2 squared, and 2x minus 1. This is your answer in factored form. And remember, the reason why we're not putting a coefficient of 2 in front of that is because we've already factored all of this. We're not missing our leading coefficient. It's already there. So we don't have to rewrite a 2 in front, because honestly, when we FOIL all of this out, we should get that answer for the 2x to the 5th power minus 5x to the 4th all the way down to x equals -4. And remember, just to remind you like we did on the last question, if I gave you a factored form on a test or quiz and I asked you to write out what the y-intercept is, you can definitely FOIL all of this out, but you don't need to. Instead, plug in 0 for every x that you see. Whoops, let's try that again. 0 for every x that you see, and then simplify it from there. This is your final answer. Okay, the last question we are going to look at is number 6. So let's go ahead and flip our page over to question 6. All right, for question 6, there's only 3 terms. When there's 3 terms, you can probably factor. So if I was to try to factor question number 6, what's the first thing I would definitely have to do, Jenny? What's the first thing I would definitely have to do? Factor out what? A negative? Okay, is there any variables we can factor out with that? How many x's? 3. We can do x to the 3rd power. That leaves in parentheses. Be careful because I've been messing up on these signs all day. We have x to the 4th power. Double check my math and my signs. We're going to have negative 8x squared. And then we'll have, I think, positive 16. In that parentheses, you can factor that. In Algebra 2, we taught you guys how to factor something like this, even though your leading coefficient has a degree higher than 2. We talked about how to do this. If you don't remember, congratulations. I'll go through it with you. In this parentheses, the first thing I'm going to do is I'm going to make my little x chart. I need to find 2 numbers that multiply to positive 16 but add up to negative 8. To get 16, I just multiplied 1 times this 16. That's all I did. Okay, so what 2 numbers can I use? Both of these, negative 4. Even though the leading coefficient here is a positive 1, the degree is a 4. There's technically shortcuts, but I don't believe in just automatically showing y'all the shortcut unless it's for a reason. I'm not showing y'all the shortcut for this one. We're going to factor this by grouping. So x to the 4th power minus 4x squared minus 4x squared plus 16. If you're like, wait, why are we doing minus 4? We have both of these terms that if we add them should get me negative 8x squared. That's why I'm putting negative 4x squared minus 4x squared. At this point, we're going to have to factor by grouping. So group the first 2 terms and the last 2 terms. So Joseph, in the first group, what can I factor out? What does that leave in parentheses? Next group, what can I factor? What does that leave in parentheses? Notice that both of your binomials are the exact same. So I'm going to rewrite the entire problem here. I'm going to rewrite it right down below. So we're going to make this y equals negative x to the 3rd power. In parentheses, I'm going to put x squared minus 4. That was both of these. And I'm also going to write another one, x squared minus 4 here. Let me write that correctly. X squared minus 4. We could, and I'm not going to stop you, we could technically set this equal to 0 and solve. But I'm betting money 1 or 2 of you guys is going to forget to put a multiplicity because these multiplicities aren't going to stay the 1 that they currently are. Jorge, how can I factor these? Give me the 2 factors. Don't worry about the process. Give me the factors. Go ahead, Gabriel, help him. And what is that called? Begins with the D. Not cubes. Squares, difference of squares. So x plus 2x minus 2 for this first one. So factor this one too now, Jorge, by yourself. Thank you. I was like, if you mess this up, it's the same one. What do you notice about this, Jorge? Are there any that are the same? Okay, which ones? That's the only reason why I would suggest you guys rewrite them, because I know that some of y'all are going to forget to put those squares, which means you're going to forget, like Jorge said, that they're going to have a multiplicity of 2. All I need to do from here is set them equal to 0 and solve. So 0 is going to equal negative x cubed, x plus 2 squared, x minus 2 squared. I'm going to set x equal to 0 because that's for this first one. I could set the negative x cubed equal to 0, but it's not going to change anything. So just take the x, set it equal to 0. We're going to set x plus 2 equal to 0. And we're going to set x minus 2 equal to 0. All right, I'm going to solve. X equals 0 is just x equals 0. This is x equals negative 2. This is x equals positive 2. For x or negative x to the third power, Carlos, what's the multiplicity here? For this one that I'm underlining? Let's try this again. What's the multiplicity? What's the degree? 3. Thank you. I was like, please don't tell me 1 again. Multiplicity is going to equal 3. What does that mean? I know it's going to cross, but how is it going to cross? Yeah, I know it's weird, but what is it called? It begins with a C. Cubic. And then for this next one, what's the multiplicity? 2. And how does that cross? Or does it cross? It's going to bounce. And then the last one? Which means it should also bounce. Thank you, sir. Why is it cubic? Because this exponent here is a 3. And whenever it's an exponent of 3, it is going to cross through, but it has to cross like a cubic function. We talked about this the very first day. If it was x squared, that would be like this, where it's going to bounce off, and it's going to make the shape of a parabola. It's going to kind of bounce off of the x-axis. All right, last 2 things that I need. I need the end behavior, and I need the y-intercept. So the last, or second to last thing, I need the end behavior. Valerie E. My leading coefficient here is what? And what's the degree? 7. When you have a odd degree and a negative leading coefficient, what's going to happen to the ends? How is it going to look? Up, down. Good job. And then the last question, Valerie E. What's the y-intercept here? Remember, you would plug in 0 for every x that you see. So what's the y-intercept? Say it again. 0. That's exactly it. Good job. So we have all of these pieces that I highlighted in yellow. This is what you're graphing. Be careful, because I want you guys to start it off. When you graph the origin, which is technically x equals 0 and y equals 0, that's the origin, make sure that you draw a line through it, cubic. So it needs to have that cubic shape. So start graphing this out, and then I will graph it with you guys. So start graphing it out. All right, so we're starting in an up-down direction. So starting up at negative 2, it's going to bounce. It's going to cross through the origin, because remember, one of your x-intercepts is 0, the y-intercept is 0, so now have it cross through, and it's going to cross like a cubic function. So like I've been telling you guys to do, graph it up, graph it going down. I just want to see that cubic shape in the middle. And all I need to do is just connect it. I don't know why I put a y-intercept of negative 4. I was thinking of the last question. Sorry about that. And it's going to go down. It's going to approach positive 2. And at positive 2, it's going to bounce off. So let me bounce it off of positive 2. And then it's going to keep going down. Your graph should look something like mine. Just want to make the end longer. Quick question. If I asked you to write this in factored form, have we already done the factored form? Where is it? Where's the factored form? This one right here. It's the negative x cubed, x plus 2 squared, x minus 2 squared. That's your simplified factored form. That's also why I didn't just set this equation here equal, or my bad, this equation here equal to 0 and solve. It would have given me my x-intercepts, but if I ask you to write it in factored form, this would be the answer. So make sure you write it in its factored form.